In the universe, few celestial bodies are more mysterious than black holes. They cannot be directly observed, but still greedily devouring everything around. Some black holes are unimaginably large. It can even swallow countless stars and interstellar matter. As matter continues to fall, they can grow almost indefinitely. To understand the nature of black holes, you must first understand how attractive forces work. When we throw a ball into the air, the ball rises to a certain height and then falls. This is because the attractive force of the Earth is pulling him. Similar rockets want to break free from the shackles of the Earth, must be faster than the Earth's attractive force. This critical velocity is called escape velocity for the rocket to successfully leave the Earth. He needs to go at least 11.2 kilometers per second. What is the escape velocity of a black hole? He is either equal to the speed of light or even faster than the speed of light, and in the laws of physics, the speed of light is the ultimate speed in the universe. So once you cross the field of view of the black hole, even time cannot escape. This means that any matter that enters the black hole's range will be completely devoured, can't return to the universe. However, black holes themselves do not emit visible light. How did humans discover them? Although black holes seem like empty spaces in the universe, but their existence, it has a profound impact on the surrounding environment. The black hole's attractive force will capture and compress the falling material, form a blazing attack disk. The gas and dust in the speed rotation friction, the resulting extreme heat, emitting intense S-rays and gamma rays. Through astronomical telescopes and artificial satellites, humans can detect this high-energy radiation to determine the existence of a black hole. In addition, black holes can also use the attractive force effect. Expose your tracks. When surrounding a black hole of stars or star matter, when presenting abnormal movement patterns, it may mean that there is a hidden, directly observed celestial bodies. Its attractive force distorts the surrounding space. In theory, any object can become a black hole. It's just mass and density. For example, if you want to turn the sun into a black hole, its mass must be compressed to the radius only within a range of 3 kilometers. And if you want to turn the Earth into a black hole, you need to compress the mass of the entire Earth too, in tiny spaces less than 9 millimeters in diameter. It's a sphere the size of a soybean. So, could such a tiny black hole really exist? In theory, distant black holes may have formed in the early universe. Some of them are as small as atoms. What if these black holes existed? Their temperature will be extremely high, even more than the sun. It will eventually evaporate in a very short time. Therefore, even if such black holes exist, it will not have a significant impact on the cosmic environment. Some scientists even propose hypotheses. Think of the original black hole could be one of the components of dark matter. But this idea is still being explored. Assumptions aside, astronomers have indeed observed stellar black hole. Such black holes are caused by the violent explosion of massive stars, formed by a superstar explosion deep in the universe. When a star goes through the end of its fuel run, extreme fate, its core collapses, trigger a violent superstar explosion. The brightness of this explosion, it can even outstrip the entire galaxy. The black hole was born in the wake of this cosmic storm. In order to measure the mass of these behemoths in the universe, scientists use the mass of the sun as a unit. The mass of the Sun is approximately 1.910 cubic kilograms, and typical stars and black holes, the mass is usually between 3 and 10 solar masses. Humans have confirmed the existence of a black hole for the first time. S1 Cygnus is a stellar black hole. It's in the Milky Way, located about 7,000 light-years from Earth. This black hole has one unique feature. It rotates extremely fast, almost reached the theoretical maximum, 800 revolutions per second, although it has a mass of 21 solar masses. Still a small person in the black hole family. Above stellar black holes, we have even more massive intermediate mass black holes. This kind of black hole, a scientist for a long time, exploring the key links in the evolution of black holes, but evidence has been sparse. In recent years, astronomers have discovered a number of objects that may belong to intermediate mass black holes. Year 2006, astronomers in a deadly attack outside the Milky Way, Shinshuanzong, a strong S-ray signal was detected. Estimated according to its brightness, the mass of the black hole is about 10,000 times the mass of the Sun, although it is still. Its exact nature cannot be fully determined, but its characteristics highly meets the criteria for intermediate mass black holes. However, 50,000 times the mass of the Sun. True cosmic behemoth. Supermassive black holes are still insignificant. Supermassive black holes are ubiquitous in star centers. For example, the core of the Milky Way galaxy, sitting on such a behemoth. Sagittarius, a model. This black hole is massive, for 0.60 million times the mass of the Sun, but it's relatively compact. The diameter is only 17 times that of the Sun. In other words, his actual scope, it could even be surrounded by the orbit of Mercury. Although he is about 26,000 light-years from Earth, out of reach. But he is still one of the masters of the galaxy. Deep in the universe, there are a few more. Supermassive black holes are acting really weird, like NASA's Hubble Space Telescope. An extremely bright class was photographed, Star 3C186. It is located at a distance from the Earth, a galactic core about 8 billion light-years away. We thought, at the center of most stars, there is a massive black hole. But scientists recently investigated a study of supermassive black holes, brought an astonishing discovery. He actually is not located at the center of its own galaxy. Instead, he is about 35,000 light-years from the interstellar core, farther than the Sun's new distance from the Milky Way. So, a black hole more than 100 billion times the mass of the Sun. What is it like? How could it be moved to such a distant location? Researchers speculate this could all have originated from two galaxies collided 11 to 2 billion years ago. As galaxies swallow each other, black holes at their respective cores start rotating around each other, ultimately merged into one. This process releases extremely attractive force waves, and on the opposite side of the most intense fluctuations, the merged black hole received a powerful shock. Flying outward at high speed, the impact is so powerful, equivalent to a supernova exploding at the same time. Now this black hole 3C186, still in space, per hour, 7.50 million kilometers away from its parent galaxy. At this speed, it only takes 3 minutes from the Earth to the Moon. However, this ejected behemoth, how big is the big thing? It's still a mystery. Black holes need to devour a large number of stars to grow. But that doesn't mean they're like giant vacuum cleaners in the universe. Will actively inhale everything around. If the Sun, replaced by a black hole of the same mass, Earth's orbit doesn't change at all. And Since the radius of this black hole is only 3 kilometers, we still need to get closer. We'll be captured by its attractive force. Supermassive black holes are unimaginable. Of course they exist, but they are related to those known as extremes. Compared to celestial bodies with giant black holes, still seem insignificant. One of the most famous examples is located in the giant interstellar Home 15 nest, a massive black hole at the core. This galaxy is about 2 trillion times the mass of the Sun, and the mass of its core black hole, an astonishing 40 billion times the Sun, then the total mass of all the stars in the Milky Way, and more than half the size of this black hole, even the entire solar system. Home 15 stars, located in the depths of the universe light years away from the Earth quarter, and this cosmic behemoth he hides. It is still the largest black hole ever observed by humans, one for a long time. Scientists once believed that an active black hole. The theory of its mass is only 50 billion times that of the Sun. However, a recent discovery completely overturns that perception. In the universe, the brightest objects are not stars or ridges. It's a quasar. These celestial bodies are powered by extremely active black holes. It can outshine the entire galaxy. It wasn't that long ago. Scientists have discovered it. The quasar of issue 618. His brightness is equivalent to 14 trillion the sum of the suns. It even obscures his entire galaxy. And driving this dazzling, it is a mass supergiant black hole up to 66 billion times the Sun. Its scale is huge, even beyond the Milky Way, the sum of the masses of all the stars in the system. The diameter of this black hole is 390 billion kilometers, equivalent to 6 times the distance between the Sun and Neptune. Look, 618 is in the direction of Canis, about 10.4 billion light years from Earth. In other words, what we observe today, it's what he looked like in his infancy in the universe. And over the years, his quality may be far away, beyond the current number of observations. According to the information on how such a massive black hole formed, the scientific community had a hypothesis. A smaller black hole as a seed, constantly devouring matter, eventually grew into a behemoth. However, computer simulations suggest that carbon-618 doesn't fit this pattern. The more likely scenario is multiple black holes evolve in the long universe, constantly merge during the process, ultimately formed this cosmic behemoth. Despite this, we still can't be sure. How was grade 618 born? But he is without a doubt the most profound man has ever discovered. Big black hole. And here's what's even more surprising. Scientists are constantly updating awareness of the limits of black holes. As the observation deepens, some researchers have even begun to suggest a new type of black hole may exist. They're called supermassive black holes. These black holes could be more than 100 billion times the mass. The Sun is even more than that. So one wonders, if black holes could grow infinitely, will they last forever? On human timescales, black holes are almost immortal. They do evaporate at an extremely slow rate through a mechanism known as Hawking radiation, gradually lose quality. However, it's incredibly slow. For example, a black hole with a mass of 100 million tons. It requires the age of the entire universe to lose half the quality. The more massive the black hole is, the slower it evaporates. Therefore, even if all the stars in the universe eventually go out, black holes will continue to exist for a long time, quietly wandering in the deep darkness of the universe.